Let's look at another example of using law of sines. So let's label our angles and sides that were given. So I'm given c equals 50 degrees, little c equals 1, big A I don't know, little a is 2, big B I don't know, and little b I don't know. So certainly I have the requirements of a side-side angle. I'm given everything with C, so it looks like I would use sine of 50 degrees and C is 1, and try to find one of these other angles. Let's say sine of B, A. I was looking at B, since I actually know what little a is, so this would allow me to solve for big A, the actual angle. So I'm going to end up with 2 sine of 50 degrees equals sine of A. And as we did in the last lecture, how do you solve for the angle? You have to take the inverse. Now, if you just straight do this, you're going to get an error in your calculator. And you're going to wonder, what happened? Well, if I go over here and I rewrite this, 2 sine of 50 degrees equals sine of A. And then I actually put this in my calculator, I get 1.53. And you might be sitting there going, yeah, okay. Well, if you're doing that, then you don't remember about domains. So if you remember, the sine inverse has to be between, so once again, doing this business right here, has to be between, my angle has to be between -1 and 1, and that is not. So what happened? Well, this is actually what this looks like. So every once in a while you get some oddball problem that you can see that this isn't a complete triangle. And so you have to be careful with these. So let's do an example where you could even come up with 2 solutions. So once again, I have my cat in the way is the first problem. So here I have the A values, so probably I'm going to use them. 35 degrees over A equals 6, and then because I have little b, then I'm going to solve this for sine of B. All right, so I do all that crazy algebra stuff that we do, and so in other words, the cat just flipped upside down. So in other words, I'm going to end up with, if he'll leave my hand alone, stop it! I'll end up with sine inverse of 8 times sine of 35 degrees. He has a whole, let go of my hand! Yeah, over 6. And because of that last example, you want to be careful and actually put this in your calculator and get a number to make sure it's okay. And actually when I do, I'll say this piece right here, I got 0.76, okay? And so when I solve this, I get 49.9. So everything seems okay. However, based off of that last example, we're not really sure. I could also say or B could equal 180 minus this 49.9, which is 130.1. Okay, because I don't really know, do I have a full triangle? And if not, then I just have those two angles. So what I have to do is I always have to check that my A plus B, so in other words, my A plus B is less than 180 degrees. And you're going to see from the picture what's going on here. So in other words, I'm going to end up with these two triangles. So I have, once again, my A equals 35 degrees. I can look at, let's call this one B1 that we found, 49.9. And then we'll call this side over here B2, which was the 130.1. And so in this case then, if I look for C1, it's going to be 180 minus 49.9 minus A, so 95.1. Sounds like a radio station, huh? Or C2 could be 180 minus 130.1. I'm trying to get this to fit, and 14.9. So far it looks like both of these angles actually are working. So let's see what's going on. I'm going to take the sine of A over A and set it to the sine of C, this C, over little c. And so I can, let's call that little c1. I can solve and I get 10.42 for that side. This one over here, I can do the same thing. So sine of 35 over 6 equals sine of 14.9 over little c2. And I get little c2 is 2.69. So this is one of these weird phenomenon. And it's like, well, I'm not really sure which one's the answer. Well, actually, both of these work, because if you look, well, first it said there was going to be two solutions, but if you look at the picture, this is actually what's happening. So in other words, you end up, you can see my two solutions here, you end up with two different triangles. So you have to kind of be careful when something like that occurs. And we'll come back with an application.